Welcome, everyone. Can I get a quick sound check from maybe Wendy or Danielle? Thank you. Perfect. So welcome, everyone, and thank you for joining us today. My name is Tari Martin. I am a director at the National Alliance for Public Safety GIS Foundation and co-chair of URISA's Climate and Community Resilience Committee, the group that has been organizing these educational webinars. So before we get too far, I just want to mention a couple logistics. It is a webinar, so you are muted by default. So if you have questions, please use the Q&A. We'll also try to monitor the chat. So as those questions come up, please pop them in. And if we can, we might talk about them right then. Or if we have time at the end, we'll try to address as many as we can. So with that, we're very excited to have you with us. You may have seen the webinar socialized on social media or forwarded to you from a colleague. So for those of you who may be new to URISA or just less familiar, URISA is a multidisciplinary geospatial organization that provides professional education and training and a vibrant and connected community advocacy for geospatial challenges and issues and essential resources. And all that is evident by all the resources and events that they make available to the broader community, kind of like what we're doing today. So this is one of a series of webinars that are being put on by the committee, which does a lot of valuable and varied work around the impacts of climate on communities, including physical, social, and economic variables that affect our ability to be resilient and build sustainable communities. So we try to bring experts and thought leaders to provide insights and share tools and resources and best practices that can support geospatial practitioners working in any capacity in the community. And today is no exception. I'm really excited to have a good friend and colleague with us today on this extremely popular topic. And I'll come back to future webinars. Katie Picchione will be laying the foundation for our understanding of AI capabilities, and she'll discuss several use cases for AI in emergency management. She is an associate staff at MIT Lincoln Labs, working in the Humanitarian Assistance and Disaster Relief Systems Group. Prior to that, she spent several years at the Federal Emergency Management Agency, working across many efforts, including working to make aerial imagery useful to response and recovery programs, as well as serving as the crowdsourcing unit leader in the National Response Coordination Center. And I would be remiss to not mention that she's also one of the core leaders on URISA's GIS Core Photo Mappers efforts. They rally GIS volunteers who map damaged photos immediately following disasters, which provides response agencies at all levels early situational awareness in the scope and the magnitude of a hazardous event. So I will add a link in the chat momentarily for that if you're not familiar with Photo Mappers or GIS Core, which is a tremendous group of volunteers who do really amazing work. So hopefully you're already familiar with them. And at least now you know that they exist should you ever need them, hopefully not. So with that, I'm going to stop sharing my screen and I'm going to turn it over to Katie. That's not what I meant to do. Stop share. Okay. Awesome. Over to you, Katie.
Great. Thank you so much, Tari. And thanks to Wendy and the URISA committee for inviting me to talk today. So as Tari, thank you for the wonderful introduction. I think I'll kind of preface this by pointing out that I'm not an AI scientist. I've come very much from this world of technology and policy, looking at how we think about technology in our world and how we develop policies around the use of technology in our processes. And so from that perspective, I'm really excited to talk about AI in emergency management and hopefully provide some frameworks for thinking about how we can, should, want, or don't want to be using AI as this technology continues to develop. So if you have any questions after the talk, please feel free to send me an email. And as Tari said, please drop questions in the Q&A or in the chat as we go along. So just to kind of start this off, I want to just kind of start with the question of why are we talking about technology in emergency management at all? And on the screen here, we've got a chart. This is data from NOAA. It's the $1 billion disasters data set. The National Oceanic and Atmospheric Administration tracks disasters that cost over $1 billion and has since 1980. When I look at this data, what I see is that, during the period between 1979, when FEMA was formed, and 2003, when it was incorporated into the Department of Homeland Security, the US was experiencing about $4 billion disasters a year. And now we are experiencing about 1 to 2 a month. And our systems, our emergency management systems, weren't designed necessarily to contend with the severity and frequency of disasters that we are experiencing today. And so I think there's a very important question to ask of how can technology expand our capacity and capability for managing these increasingly severe and costly disasters. And AI, of course, is one tool in the toolbox that emergency managers can be using. Here we have just a brief overview of the history of artificial intelligence. AI was sort of had its roots with Alan Turing, who was the father of computer science, thinking about, what does it mean for a machine to be intelligent? What does intelligence actually mean? And in the latter half of the 20th century, there was a period of a hiatus of AI research. They called it the AI winter, when really very little research was done in AI. Some of that was spurred by concerns over misuse of technology, a lot of it following on World War II and the Cold War. But recently, in the last 20 years, with advances in computing technology, a lot of research has been done on how to use machines and computing to imitate the way humans think and do things. And so now, of course, we have all sorts of tools that are available and increasingly available that there's a lot of hype about, using new AI methods to mimic what humans do. And just as another example of this, this is a survey done, by Forbes and Sequoia in 2023, looking at sort of the top 50 AI companies. And I don't get I look at these logos and I try not to get bogged down in it. The real point here is that AI is now exploding in business, in research, in the open source tools that are available. And so there are now more and more AI models and AI tools than there have ever been before. And it begs the question, AI seems to promise a solution to all problems. But like any new technologies, right, applications in emergency management seem out of reach, I think, for a lot of us. Like, we see AI and many technologies as having a lot of promise for facilitating what we do in emergency management. But I think I have, in my experience, emergency management is sort of chronically 20 years behind in our ability to use technologies that have been around for a while. And a lot of that is because tools aren't really developed or designed for the emergency management community. And now some of these generative AI tools that are out there, pretend to be available for all use cases and all applications, including emergency management. And so there's sort of this question of, well, what's real? What can we use? What can't we use? Why can and can't we use it? I don't necessarily have a clear-cut answer to this question, but throughout the course of this talk, I'll plan to address it. And so I have three takeaways. I'm just gonna put these things up front. AI models, what AI is good for is identifying and replicating complex patterns. So AI is really good at pattern matching and expansion. And that's important because some things are patterns of life and some things are chaos. And so for me, this is really a core piece of understanding what AI is good for in emergency management. The next key point is that the available tools can help reduce information overload and routine tasks. There is applicability, of course, in this area. But AI is not an oracle that will solve all problems. AI is not it's not magic, it's not a deity, it's not an oracle. This is a tool set, just like any other tool set, that we can use and design and shape to meet our needs. But it's not a replacement for thinking, right? So I've got three things I'm going to talk about. First, I want to lay some groundwork for understanding how AI works, talk a little bit about use cases for different types of AI models in emergency management, and then address some challenges and concerns. And at the end, I'll share some other thoughts of how we can use the free tools that are available right now. And so first, what is AI? I think of AI as big statistical models that characterize and replicate complex patterns. If you go and Google definitions for AI, this isn't the first thing you'll come up with. Or if you ask AI what AI is, this isn't the first thing it'll say, right? Usually AI is defined as machine intelligence or using computational approaches to mimic, human behaviors. But really, when it comes down to it, AI is a computer program that does complex pattern matching. So some examples of what that means. I think we can look kind of back to more classical statistics to get a sense of what these different statistical models do. This is a picture of just like linear regression, right? We've got a set of data. We can find trends in the data through various approaches to like observing computationally and mathematically describing the relationships of trends in data. Another example is clustering, right? Like this is another way of looking at patterns in data, is looking at where various data sets are, or various data points are similar and related to each other. So we can look at like finding trends, we can look at finding clusters. A third example is, this is an illustration of gradient descent, which is when you're looking at data, three-dimensional or more dimensional data, looking for local maxima and minima. It's an approach to optimization. And it's a mathematical approach that's utilized in many AI models. And so like, this is what AI is doing under the hood, not necessarily these three statistical methods. There are many other computational approaches that are utilized in AI, but this is the kind of thing that is actually going on when an AI model is, or in the way AI models are designed. In terms of how the actual tools are developed, there are three components that are essential to creating AI tools. And the first one is data. I don't think this will come as a surprise to anybody, but it takes a lot of data to train AI models. And so regardless of what the end use is, there's a lot of discussion right now about what they call about like few shot learning or zero shot learning, where you can develop an AI model that then is able to like take in one example or no examples of a thing you might want it to produce and then produce that thing. But in order to create those models, a lot of training data is still required. And that might be structured data that's labeled, such as images that have been annotated, or it might be unstructured data, like all of the text on the internet. And so regardless though, a lot of data is needed to develop AI tools. The second main component is having an architecture or a design of the model. And so this is one example of a transformer model, which I'll talk about some more in a moment. But the design of models, I think of it kind of like a factory. Like you put raw material in and you get some product out. And in your factory, you might have a melting and pouring and cooling and forming or cutting, right? And all of those processes do something to your raw material to turn it into the desired output. That's what happens to data in an AI model. It's a sort of a gross simplification, I think, and people who are computer scientists might rail against that. But at the end of the day, that's like, you have to design what that process looks like. And that's the model architecture. And then of course you have to train the model to have the desired output. So that in your factory, that's like setting up your offsets and tuning your dials so that the product is machined to tolerance, for example. And that training process basically takes all of the parts and pieces you've put together in this architecture and tunes them so that the thing that is generated at the end is what you actually want. So these are like the three components that are involved in developing AI. I'm going to talk a little bit more about some architectures that are probably familiar, Again, those who are familiar with this domain probably know this already, might be new for some people. I guess older set of models now that most people have probably heard of are neural networks. And what neural networks are is, again, it's a series of processes where the outputs of one set of processes are fed into another set of processes, are fed into another set of processes until there's an output. There are many, many, many different types of neural networks and neural network designs. I'm not going to go into them all, but the basic concept is that you have some input, which is then processed into some next set of inputs, which is then processed into some next set of inputs. And just as like in our brains, some inputs are more or less likely to generate some outputs because of the way our neurons are connected, or because in this case, the way different neurons in a neural network are weighted, that influences what the output looks like. And so in training a neural network basically results in having all of these different neurons tuned, or have like coefficients you could think of to produce output to that then is processed in the next layer. Another type of model that people may have heard of are generative adversarial networks, or GANs. This is sort of like in the development of AI models, GANs sort of came after neural networks and neural network architectures. And the basic principle of GANs is basically pitting one neural network or other model architecture against another neural network architecture that evaluates the output of the first one. So you might have noise or some input go into this generator model, which will produce a synthetic output. And then the discriminator will compare that synthetic output to real data and provide feedback to the generator. So it's kind of, there's this feedback mechanism where the model trains itself. More recently, a model architecture that has become very popular are generative pre-trained transformers, or GPTs, transformer models. And the basic mechanism underlying transformer models is that in any given data set, each piece of the data has some relationship, bears some relationship to every other piece of data. And so transformer models leverage this thing called an attention mechanism, which basically shows the relationship between every piece of the data and every other piece of the data. So in this example here, there's a sentence, and the attention mechanism in the transformer model basically relates each word of the sentence to every other word in the sentence, and has a weighting of the strength between those relationships. What this allows transformers to do is to basically look at a whole data set at once. So not just as you're writing a sentence, predict what the next word would be in that sentence, but for example, in a whole body of text, predict what the next word would be based on that whole body of text. And so GPTs, as most people are familiar with, I assume, this is the technology that underlies a lot of the large language models and other tools that are kind of becoming popularly available. And so most of what I'm going to talk about in the next few slides is based on transformer architectures, although I'm blurring lines a little bit. But I wanted to just kind of lay this out as an important piece of understanding kind of what is AI and how does AI work. I'm going to check the chat to see if there are any questions so far. It looks like we're good.
Yeah, so far so good. I think everyone's just really intrigued about what you're saying.
Okay, great. So moving on, in the next couple slides, I'm going to talk about 3 different ways that we are using transformer models and other models as well, but 3 different ways that these newer AI architectures are being used with regard to processing words, images, and maps. And so first and foremost, words. Natural language processing is a term that's been around for quite a while. It's the idea that we can use computational methods to interpret and produce text. And so large language models, LLMs, are the newest rendition of natural language processing that relies on transformer architectures. Basically, you have some text input, The language model, which has been trained on vast bodies of text generated by humans, then produces a text output based on your input. And so there are a couple core things that language models do, a couple core pieces of functionality. Language models can parse and interpret a text-based input. They can generate new text. They can encode and decode text, which think like translation, or it's the mechanism that would be used in like a speech-to-text application. And then they're good at searching as well. You can perform search functions from a knowledge base. And so some challenges, right, with large language models, and again, this is, I think, is probably familiar to a lot of folks, but they can make stuff up. They're not language models aren't a search engine where they're, you know, although some of them are connected to search engines, but they aren't a search engine where they're able to like find pieces of information through this vast set of training data they've been trained on, but rather they recognize the relationships between different kinds of words, and so can produce an output that mimics the way different words might relate to each other, right? And so they come up with stuff. They make stuff up, or rather, the output is sort of statistically weighted to sound like something somebody might say. Some language models now are outdated. So like they haven't. If the model was trained 3 or 4 years ago, it will produce text that looks like the way things were written 3 or 4 years ago. That can be challenging when using language models to write code, for example, or to draft code. They're prone to bias, error, use of language models for mis and disinformation is a challenge. And so when I look at the role that language models can and will likely play in emergency management, these are the kinds of use cases that I think the research and practitioner communities are looking at. Can we use models to draft or to evaluate plans, be that mitigation plans or hazard incident action plans or other kinds of plans, writing and evaluating grants, automating public alerts, developing plans for exercises, writing code. These are all kinds of products that we think language models have some role to play in helping us write and do those things more efficiently. They can also extract and summarize information from documents. My group at Lincoln Lab is doing a program right now where one of the things we're hoping to look at is how good are our language models at extracting information from situation reports or from sources on the internet. And then translation is another application in emergency management. With regard to images and using AI to process images, computer vision, again, like natural language processing, computer vision has been a field of research for well over a decade and a half now. Where transformer models, vision transformers in particular, are making new capabilities available. So AI with regard to images, the kinds of functions that we're looking at are image interpretation. So whether that's detecting change between two images or classifying features in images, annotating images. These are like more traditional computer vision functions. These newer models are also able to generate or enhance images artificially. So concerns, right, include deep fakes and the use of images to spread misinformation or stir up public sentiment in general. Artifacts in images is a concern. And then in terms of creating models, there's a paucity of training data in emergency management to train models to do useful change detection and feature classification. I'll share an example in a little bit of some work we've done in this area. But then the applicability for image vision models of various kinds in emergency management include functions like imagery-based damage assessments, filtering images, either images collected in the field or images collected from the internet, right? But finding images that are useful. These transformer models can do that kind of function much better than we've been able to do it with other computer vision techniques in the past. And then another thing that I think is probably a likely good use for these models is generating images for public messaging or other things where you might use a stock image normally. This is an example of what like labeled images, what it means to like label or annotate images is to identify like, are there buildings or flood or damage or roads in the picture, features of interest. Okay, and then the third area of the third application area, of course, is with maps. GeoAI is the term that's now being used to talk about the utilization of artificial intelligence in mapping applications. The three basic functions, at least as I see them, that AI models can do with regard to geographic data are spatial analysis, geolocation and geocoding, which is a perennial challenge, especially with imagery, and then geophysical modeling. And so I'll actually let's talk about each of those in relation to the likely near future uses in emergency management. But spatial statistics would be like taking your geographic data foundational layers and developing new population or land use estimates, or looking at what kinds of features might be most likely to be affected in a certain kind of incident, right? These processes that we as geospatial analysts would typically do through other kinds of modeling approaches, we can now use AI in that modeling as well. Remote sensing analysis is a huge area that AI models are being used for. One of the challenges in particular with remote sensing is that remote sensing data is really big. And so while AI models are able to actually process that data more efficiently and effectively than traditional approaches, running those models also requires a lot of compute power. So there's sort of a trade-off between functionality and resource requirements. And then, hazard and vulnerability modeling, real-time or near real-time forecasting. These are all applications where AI is being used, again, to find patterns in data that are more complex and extrapolate that complexity basically for predictions. So anyway, right, challenges include data availability, compatibility, development costs, and the interdisciplinary collaboration required to kind of bridge the gap across GIS, remote sensing, and emergency management. Okay, I have a few considerations I wanted to share when we think about putting AI tools into practice. In my group, we talk a lot about use cases for AI, use cases for imagery, use cases for other things. But we've also been talking a lot about what does that mean in the context of AI. And so the first kind of component of use cases for artificial intelligence in emergency management includes understanding your business processes. Who's your user? What's their role? Is the intended use of this tool for a gray sky application or a blue sky application? Does it need to be operating in real time, or is it something you might use every now and then to generate a certain type of report that'll be around for a while? What is the primary function of that tool? It can be any of the things I've listed previously, or I've summarized using this framework we talk about with data science more often: descriptive, predictive, prescriptive analytics. I've added generative function to that list. The second component of things to think about with AI use cases is how will that system be deployed? I'm using this word architecture again, which I realize is confusing with the way I used it earlier. But what does the data pipeline look like for actually using AI in real time? Do you need this AI capability to be hosted offline on a local network, or is it something you can access through the internet? Are you trying to use the tool on a desktop or mobile application? Do you need would it be an API-based application? Design of the user interface. All of these things are relevant when talking about how we actually would implement a tool for use in this community. Other considerations include the ability to use a commercial or an open source language or open source tool, whether you can use the model just as it is or whether you need to train it some more, and how it actually will be hosted. And then there are the architecture and requirements sort of go together, right? The requirements would talk about the things that the architecture needs to be able to do. And so requirements in emergency management include thinking about privacy protection. Are you allowed as an agency or as a public entity to share data with a commercial LLM provider, for example? Or is it something that you really need to run on your own system? How big is this model? How much compute power does it require to run? Are there additional considerations? Are there additional restrictions you need to consider around storage capacity, security, cybersecurity requirements, and authentication for access? So these are some of the parts and pieces that we're thinking of and thinking about. Okay, how do we actually take AI tools and put them into practice in our systems? Because there are some use cases for which it's totally fine, like go on ChatGPT and ask it a question, and other use cases like analyzing situation reports where it might be inappropriate to share that data with a commercial provider. So I'm going to share a quick example of some work my group did recently with the Civil Air Patrol. So the Civil Air Patrol is a federally chartered nonprofit. It functions both as a federal agency and as a volunteer group. And during disasters, the Civil Air Patrol has a mission where the federal government or a state government can task them to go fly up in small aircraft and take aerial photographs using handheld cameras. These photos provide a lot of very important information during disasters, but often thousands of photos are collected and it can be difficult to find ones that are actually informative. And so my group has done some work over the past few years looking at different ways that AI could be used to create filters for these images. And so this is an example of, again, of the outputs, right? We're looking at, okay, for these aerial photographs, can we have a model look at the photo and tell us whether there's a road in the photo, or whether there's a damaged house in the photo, anywhere in the photo, or whether there's flooding in the photo. And so we worked with the Civil Air Patrol to develop a new set of training data, basically to create a set of labeled images from their vast repository that we then used to train a couple of image transformer models. We actually took 25 open source transformer models, did fine-tuning training on all of them, picked the top 2 candidates, and then trained those, did additional training on those 2 models. And we found that these models are able to, they're very good at identifying. This is a spider chart, by the way. Sorry, it's a little, I should explain it if I'm going to put it on the slide, but basically one way of evaluating model performance is with a metric called average precision, which is like an estimate of, you know, how accurate is the model, right? It's one of the metrics for describing accuracy. And so these models had a very high average precision for identifying whether there are houses or roads or water in photos. And they did less well on evaluating whether there are damaged versions of those things in photos. But the tool itself, we've been pretty pleased with spot check outputs. I plan to kind of pull up the, I think if we have time at the end, I'll pull up the demo viewer that we've created, and I'm happy to share the link. But basically, you know, we've developed this tool now that we'll be publishing open source sometime, hopefully in the next few weeks, that, you know, takes in oriented images and creates labels for them so that you can filter through the images. And so we've been in talks with colleagues in the emergency management community about how to actually put this tool into practice as well, which is really exciting. Like, it's been a really fun project to be part of. And so I think this kind of leads me to, I'm actually going to stop sharing for a minute. This leads me to the next set of topics which I wanted to discuss, which is, like, it's great that we, you know, have all of this new technology available. It's great that we're finding ways to utilize it effectively in emergency management. But how do we do that responsibly? So earlier I emphasized that AI is really good at characterizing and replicating complex patterns. But a disaster by definition is chaotic. It's like a chaotic deviation from the normal patterns of life. And so like, in the course of preparing this talk, I've thought deeply about the challenges and concerns related to the development and use of AI in emergency management. And I'd like to address briefly both the practical challenges surrounding data, resources, and skills, and also some of the ethical and philosophical considerations. So first off, data, first off is challenges with data. And despite the glut of data that we seem to have in this world, with an estimate of over 64 zettabytes in existence, this is a statistic from the International Data Corporation. A zettabyte is, I think it's like a million petabytes, which is a million gigabytes. So it's like a million gigabytes. It's like a lot of data. But despite this, we seem to continue to have challenges finding the right data, both to use in emergency management applications for AI. And so quantity, quality, and consistency are concerns both regarding training data and for using some AI models operationally. So data pertaining to disaster operations like damage assessments, search and rescue activities, lifeline status, and grants administration are protected. These data aren't just out available in the world, and rightfully so. So it's hard to get training data sometimes. And then in addition, like different agencies collect and use data in very different ways. And we lack standards for many different data types, such as situation reports, where there are as many versions and designs of situation reports as there are people producing them, right? Or as organizations producing them. And so as a consequence, generative AI tools, these sort of general artificial, or what they call artificial general intelligence, right? Or tools that are designed to have this sort of general intelligence, they provide mixed results, and custom tools are difficult to develop. So there are challenges regarding data availability, access, and utilization in emergency management. The second topic, or the second challenge in utilizing AI in emergency management is resources. It takes significant investment on the part of agencies and companies to develop useful tools, plus ongoing allocations to keep tools running. AI tools require large compute resources to develop and run, typically leveraging GPUs in data banks or cloud services, which are, and so they're like the investments required to develop tools are costly. And then in addition, there's sort of an art to designing tools that are useful and actually solve real problems that can integrate seamlessly into operations. Developers need to have close engagement with subject matter experts in order to identify use cases for AI where the investment to develop the tool is worth the value they provide. Like if the tools available are just mimicking functions that we already have tools to do that, like it's not really worth the investment. Or if the tools are automating something that a person can do better or cheaper or faster or better, right? Usually better, that it really isn't, like it's not worth the investment. And so this brings me to the third challenge, which is about skills and adoption. And I know I'm kind of preaching to the choir here, but many agencies lack staff with technical backgrounds who can develop, evaluate, and deploy AI tools. And I think we often see this with geospatial technology as well, right? Like there's a capability gap between what we want to be doing and what we're actually able to do. A lot of emergency management agencies just straight up don't have geospatial analysts, and the gap is even bigger with regard to AI and computer science. And so as a result, the commercial solutions with intuitive user interfaces are attractive, but they might not always be the right tool for the job. There are rich repositories of open source AI models and tools, but developing and implementing custom solutions in-house is out of scope for many public institutions. And so a consequence of this is like a lack of champions who can discern which new tools and technologies will actually be useful and mediate their adoption. Right now, these roles are kind of split across organizations who are developing and wanting to use AI. And bridging that skills gap is important. And so, like at the end of the day, not all AI tools will actually provide value. And so we need to identify use cases where full or partial automation will increase our capacity and capability. In preparing this presentation, I made accounts on 5 prominent free LLM-based platforms, which I'll talk a little bit more about in a bit. But I asked ChatGPT to write an outline for this talk, and it was pretty generic. I wasn't impressed. It was mediocre. I tried using these tools to draft code and other content, but I felt more frustrated like editing the mediocre outputs than just writing and scripting things myself. This is like anecdotal, but I realized that you have to already know what you're doing to make good use of some of these tools. And so AI is good at pattern matching, but it lacks judgment and embodied knowledge. AI doesn't have the same view of the world as we do. And I know there are researchers who are working on changing that, but the fact remains that you have to know what you're doing still in order to use these tools. Additional concerns around the practical use of AI tools include equity, environmental impact, and the incidental production of harmful content. Biases in training data could lead to unintended outcomes, with some groups underrepresented or with bigotry baked in. Data centers needed to train and run AI models consume enormous amounts of energy and water, which is used for cooling. And so there's a significant environmental impact affiliated with the development of use in AI. Large language models frequently produce content that sounds authoritative, but is not true, as we were talking about hallucination before. And some image generation models have been found to include off-topic, troubling content, like unnecessarily adding guns to images. So these are important considerations as we develop and adopt artificial intelligence solutions, especially in emergency management. Scholars, science fiction authors, and increasingly journalists, policymakers, and companies, and us, right? We're also asking whether we should develop and adopt AI at all. And if so, how do we do so in a responsible way? If AI models voluntarily produce false content, what's to stop a malevolent actor from intentionally using AI to develop conspiracy theories, misinformation, fake images of Taylor Swift, and other nefarious content? Does the virtue or vice belong to the device itself, or is an operator morally responsible for outcomes? And I think a topic closer to home is that while AI promises to alleviate the burden of monotonous tasks, and in the context of emergency management, particularly to stave off burnout, how do we balance efficiency with dignity of work? So I pose these questions. I don't necessarily have answers to them, but they're important things for us to be thinking about. Taking a step back, scientific inquiry ranges from basic research, asking questions about how the world works and seeking answers through rigorous reasoning and experimentation, to applied science. And the latter is sometimes referred to as technoscience, which revolves around developing tools to achieve human goals. A classic example of this is basic science can include the study of nuclear physics. Technoscience uses knowledge of nuclear physics to develop radioactive isotopes for medical imaging or for nuclear weapons. And so in questions of good and evil, I posit that regardless of the intentions of the end user, technologies embody the values, virtues, and vices of their designers. Yet still the end user, through disposition and action, may either abuse tools that are designed for good or turn swords into plowshares as well. And so in other words, we are morally responsible for our actions, regardless of how technologies are designed. But we can also design and influence the design of technologies for better or worse uses. And so a key value that there's a lot in this topic, but a key value to inspect is efficiency. The idea of efficiency has roots with economists of the late 19th century and the Industrial Revolution. AI can certainly make workers more efficient, which reduces both burden on them and in some cases also reduces the number of jobs available. In emergency management, we already suffer from a labor shortage. Last year, the Government Accountability Office found that FEMA has chronically failed to meet its staffing goals, falling short 35% in 2022, and in some recent years has seen as much as a quarter of its workforce turnover. And so what this means is that each person is essentially doing 1.5 people's jobs, and those people are changing constantly. My current assessment is that AI tools will enable emergency managers to do their jobs better and to reduce burnout. And that I think is really important. The greatest risk I see in using generative AI is the slow but steady reduction in skill across the workforce. Just as we now outsource math to computers and many industrial arts to machinery, not universally, but in many cases, generative AI offers to expedite writing and other content creation. And these are core communication skills across disciplines, regardless of discipline. Their degradation is detrimental to society. It seems to me that we can mitigate the loss of skill while reaping the benefits of automation by developing custom tools for specific applications rather than general tools that posit to solve all problems with mediocrity. I think it's really important that we as a community are skilled and are able to maintain our high standards. Because AI tools haven't impressed me yet, and they're wrong a lot of the time. There's a global conversation taking place about how to develop and use AI for good, right? We're seeing motion toward regulatory action that will influence the unfolding of AI in society. With President Biden's executive order last October on safe, secure, and trustworthy artificial intelligence, and the European Union's AI Act, which was passed earlier this week. Similar measures have also been proposed in the US Congress for regulating how AI is developed and used. Since 2021, 193 UN member states have signed on to UNESCO's guidelines for AI ethics, which include the following 10 core principles: proportionality and do no harm, safety and security, the right to privacy and data protection, multi-stakeholder and adaptive governance and collaboration, responsibility and accountability, transparency and explainability, human oversight and determination, sustainability, awareness and literacy, and fairness and non-discrimination. So, and while putting these principles into practice across varies across domains and disciplines, I look at this list and I see that these values are closely aligned with the values at the heart of emergency management. And so I really see AI as an incredibly powerful and useful set of tools that we can and should be using. But these considerations are, I think, really important for all of us to be thinking about as we, forge ahead with using these tools responsibly. And so with that, I have one last thing I want to share, which is addressing this question that I suspect many people came to this talk today with, which is, what free large language model tools can I use today? We've all been hearing a lot about ChatGPT and other technologies, so I took a stab at addressing this. As I said, I made free accounts on 5 platforms: ChatGPT, Microsoft's Copilot, Google Gemini, Anthropic's Claude 3 Sonnet, and Mistral AI's LeChat large model. So I just did a quick assessment of what the strengths of these different platforms are with regard to, do they provide drafts of the content? Can you ask it to regenerate and create another version of the same thing? Do they cite their sources, right? Can you use them to generate images? Actually, I think with Copilot, you need to be logged in to generate images, whether an account is needed. Copilot you can use with any Microsoft account. So if you have an enterprise Microsoft account through your organization, you can log in and have access to Copilot. But then, do they search the web? Can they reach back to the web and cite their sources, or do they only produce content based on their training? And then do they have image capability as well? So this is just a quick assessment of these different tools to actually get a feel for how they work and what they do. I asked them all the same question. There's a lot of text here. It's large language models turn out to be quite verbose. At least that was my assessment of them. They're verbose and they like bullet lists. But I asked each of these models to write I gave it this prompt: write a National Weather Service flood watch alert for towns in Connecticut and Massachusetts from the afternoon of Wednesday, March 6th through Thursday evening. There was a real National Weather Service alert in effect for that time period. And so I live in Massachusetts, right? So this is close to home. And some of the things I pulled out of the actual real National Weather Service alert are specifics about the fact that the morning commute may be impacted, especially on I-95, names specific roads, talks about things that are relevant to our communities, like checking your sump pumps. In the Northeast, when we have flood watches, they're often for you might get an inch of water in your basement kind of floods, not your whole town is going to be washed away kind of floods. So, and I know the nature of flood watches varies across the country, but ChatGPT told me to prepare for evacuation orders and turn around, don't drown, which I was tickled by that. I liked that. it pulled that in. So I thought that this was quite extreme given the context and the ask. Claude had some different kinds of details that it provided. So a different structure, first of all. And then it gave me a specific inches to expect, which was cool. Noted, flooding of rivers, streams, streets, poor drainage. I thought that this was, again, generic, but it lacked some of the specificity that I would have been looking for. Gemini, I think the one from Gemini was probably the one I liked best. Called out basement flooding, called out, commuting impacts on I-95, and then it actually gave the correct link for, for National Weather Service alerts. Copilot, I think, was getting ready to post on Twitter. The thing I really liked about Copilot, look at these little icons it gave me. It was adorable. The thing I liked best about Copilot is that it also gave me a link to the National Weather Service page. directly. And as I mentioned before, Copilot cites its sources. So I thought that was cool. But the content itself I thought was banal and fairly generic. And then the last one, LeChat, noted an amount of some inches that you could sub that in. Talked about landslides, turn around, don't drown, give us a link. But then maybe most importantly, it said this is a simulated alert. It is not an actual warning or watch. And so this is the end of my presentation. I am happy to take questions I know we're kind of running short on time, so I'm happy to take questions or follow up over email. And thank you all very much for joining.
So we do have a couple questions. Are you able to open the Q&A?
Yes, let's see. Okay. Let's see. Tim Nolan asked, should we jump in now or show patience in what GeoAI tools prevail? I think if you are like in a position to use AI tools in your organization, there's no reason to not to try them out. I think across the board, like proceed with caution, right? Like there's this question of how do we evaluate that a tool is useful, and a lot of the times the answers to that question are really use case dependent. So if your organization is comfortable with you incorporating GeoAI tools into your processes, there's no reason not to try them out. But I would also, I guess, don't pin all of your decision making on them would be my recommendation. Like there's a lot of work going on in the research community on GeoAI. And I think that at least my perception of it is that a lot of it is still fairly nascent. But that, where agencies are starting to use AI in like weather forecasting, like, I don't know, those tools are, I think it's sort of their responsibility to evaluate the quality of the tools that they're incorporating. So that's my commentary on that. Tim also asked, do you anticipate any AI ethics in the near future? Yeah, as I said, there's a lot of work going on in the policy space to come up with guidelines for the ethical use of AI, and there's action being taken on regulatory action as well. What do I think about GeoGPT? I have not played with GeoGPT, so I don't have any. I actually don't have any comments on that. But thanks for the question, and I'll check the chat as well. Or let's see. So we have a lot of things in the chat. Okay. Great, thank you. I'm glad many people found it informative. There will be a recording, yes.
And then we got one more chat at the end, which I thought was something that I thought was really great about your talk was the loss of skills is a real concern. As a parent of kids who can't write cursive, I can only imagine what AI could take away from them. So appreciate that.
Yeah, I think that's I personally, I think that's the like greatest risk of AI and a lot of these tools that are kind of easily accessible. Like there's amazing capability available that's never been available before, but also like we I don't know, I love learning, right? So I'm always trying to like learn new things, but maintaining our ability to excel at some of these basic skill sets is really, really valuable and important.
Awesome. Thank you so much, Katie. I think this was a great AI session for us to have first, because you really did kind of lay the groundwork for some sessions that we're hoping to have again. So maybe the GeoChat GPT will be something that we can look into and invite other experts. I know we had some PDC here today who's doing some AI. So I think the number of webinars on AI are probably unlimited. So what I want to do is, so I know we only have 5 minutes left, so I'm going to share some upcoming things that I want to make sure are on everybody's radar. Okay. Awesome. So thank you so much, Katie. I want to make sure I get that in before we get to the end. I really appreciate your time today and all the effort you put put together this amazing presentation. And we have more coming. So right around the corner, we wanted to make sure these were on your radar. So next week we have GIS workflows for urban heat mapping, which is being done in collaboration with Esri. And that webinar will introduce simple GIS workflows for identifying and analyzing urban extreme heat. And then in a couple of weeks, we have the role of GIS in flood hazard identification, analysis, and solutions. And for that webinar, we'll have experts from the Flood Science Center who will provide an overview of the role of geospatial professionals in developing and validating FEMA's flood maps, collaborations between GIS professionals and floodplain managers, and many more topics. I think that one's going to be a packed agenda. And then URISA has a lot more going on outside of this committee. Let's see. So a few more webinars also right around the corner. King County, Washington, Smart Building Management System, Pulaski Area Geographic Information System on damage assessment and emergency response programs. That sounds really interesting. I don't think I ever say this right, but Cayuga County, Ohio, maybe it's close, on their fiscal GIS hub. After that, GIS Evaluation Technologies Conference, URISA GIS Leadership Academy, which I've never been, but everyone says it is phenomenal, coming up. And then the Advanced GIS Leadership Academy also. And then one of the biggest conferences of the year, GIS Pro in Portland, Maine. I've never been, I'd be super excited to go. I'm hoping to be there myself, but it's a really great conference to network with all GIS people of all walks of life. URISA really does build an amazing community of GIS people. So if you need an excuse to go to Portland, Maine, this is one I would highly recommend. And then before I leave, I want to add in, and yes, please submit a presentation proposal. If you were interested in the topics that today and some of the other ones that the Climate and Community Resilience Committee will be hosting, and you want to be a little bit more involved, either super involved or maybe just be a little bit more involved, I'm putting our some information links to URISA's site and then also the Climate Community Resilience Committee site in the chat also. So that's it. There you go. So with that, please join us again for future webinars. Thank you again, Katie, for your amazing presentation, and Wendy and the URISA team for helping put all this together. And with that, I will say have a wonderful rest of your Friday and weekend, and hopefully we'll see you back next week. Take care.